so we have a bunch of different lines here, and they all have different slopes. Remember that slope is another term for like the steepness of a graph. How steep is it? How shallow is it? Is it something that would be hard to climb if you're climbing a hill, or is it something that would be easy to climb if you were climbing a not hill that was more flat? Okay. And so for each one, we think about slope as being the over and up. Like I was just describing to you how to do these. That's actually the mathematical way we do it, except we give it a name. So we start by drawing in a growth triangle. So let's go ahead and draw in a growth triangle for each one of these. So that's just going to connect any 2 points that are lattice points. And I think Ms. Reisman used this term, but a lattice point is any point that falls on the grid. L-A-T-T-I-C-E. So a lattice point, which means it's on the grid. A non-lattice point would be something that was in between, so like it was more of a fractional value or something. Okay, so go ahead and do that for each of them. And the lattice points aren't always so nicely dotted for you. Sometimes you just have to look and figure out where they are. Okay. And so for each one, those little triangles kind of show us how steep it is. So hopefully we can see from this that these two both look pretty steep. This one's the shallowest. This one's going to have the smallest slope. That one looks kind of neutral. That's like in the middle somewhere. Now for each one, on each graph, we're going to write down the change in the y value and the change in the x value. And so for this one, the change in the x value is 1, goes over 1, and the change in the y value is 2. And our fancy math term for that is the delta x. The triangle is the Greek letter delta, and so we write it with a triangle, and that just means change. So delta x means change in x, and then delta y is the change in y. Change in y. Okay? And when we're calculating the slope of this one is 2. And so we have a formula for that. We can say that it's the change in y, the 2, over the 1 as a fraction. So our slope here would be delta y divided by delta x, which is 2 over 1, which is 2. Go ahead and pause and try and do it for the next one. So on this one, hopefully you identified that the y was a 3 and the x was a 2. However, we have to take into account that this one's going the other direction. So like this graph over here was going up when you read it from left to right. This one over here is going down. It's going the opposite direction. So if you were to like, sometimes people just like draw a little slope dude walking, and like this guy's gonna fall down the hill because he's going down. So the y value went down, so we make this a -3. And then the y value went over to the right, so that's a +2. So the slope for this one, my delta y was 3, my delta x was 2. So I do delta y divided by delta x, which is -3 over 2, which is -1.5. So my slope here, or my m value for the equation, is -1.5. And if we look on the graph, that should actually look to be just about right. That if I went over 1 here, that's at roughly 1.5, right? My little slope triangle there would still be a 1 and a 1.5. And I know that's kind of messy and hard to read, but that's a 1 and a 1.5. So they can scale up and down. All right, let's do the next one. Try and calculate the slope of the last two graphs, please. Okay, so for this one, hopefully you got 1/3 because it's going over 3 and up 1. And on this one, you draw a little dude, he's going up, right? So this is positive. This is 1/3. And on the last one, it should be a -1 because it's going down. And the best way I have to explain the steepness is you always evaluate steepness from left to right. As you're scanning from left to right, is it going up or down? So let's go ahead and finish out our equation for each of these. So for the first one, each of these is our m value, right? That's m. And so if we were to write an equation in y equals mx plus b format, hopefully you already did that video. The m is the slope, the b is the y-intercept, and on all these we made it so we could just see the y-intercept, which makes it easy. But I am going to teach you how to solve for it if you don't have it easily available. Intercept, there we go. So then for the first one, I'm going to write y equals, slope is 2x, and then the y-intercept was -1, so 2x minus 1. Take a moment and write the rule for the other three as well. So on the first one, we had y equals 2x minus 1. The next one, the slope was -1.5, so my rule is y equals -1.5x and then plus 2, because my y-intercept up here was at 2. On the third one, y equals 1/3 x plus 1, because 1/3 was my slope, my y-intercept was at 1. And on the last one, my rule is y equals -x minus 1. That -1 is right here for the y-intercept, and then the slope of -1, I also could have written this as y equals -1 times x minus 1, but I'll just do that and get that equals -x. Now, what if I give you one where it's not all nice and pretty and small, like the examples we just did? So let's say we have a line. I'm purposely not doing this on graph paper because I don't want you to be able to count. And let's say I have one point that is at -3, 6. And let's say I have another point that's at 25, 31. I want you to take a minute and see if you can figure out what is the slope. Find the delta y. Find the change in y. Find the delta x. What do you think it's going to be? So hopefully you're kind of picturing our slope triangle here and knowing that on our x coordinates, this is x, this is y, or on our coordinates for our points, this is an x, this is a y. This is the x coordinate, this is the y coordinate. I want to keep them separate though. So I'm going to say this is my first point, so I'm going to say it's x1 or sub 1 with a little 1 next to it. This is y sub 1. This one's going to be x sub 2 and y sub 2. That's just to keep my 2 points separate. So now, how far apart are these right here? If we picture the x-axis, right, this is at -3. This one's at 25. So really what I'm looking for there is how far away are 25 and -3. One way to do that is by subtracting. So I can do 25 minus -3 gives me 28. And then for my y values, same idea. I'm trying to figure out how far apart are 31 and 6. What's that distance in between there? So I can do 31 minus 6, and that gives me 25. Well, this is my delta x. This is my delta y. So that gives me delta y over delta x is 25/28. Not a pretty slope, but it's an accurate slope. And we know that because we calculated it using math. Okay, so for our practice problem, if you had any 2 points on a line, I'm calling them x1, y1 and x2, y2, just 2 random points, how could you find the slope between them? This is a hard question. You might need to go back and look at the page from before, this page. It's okay if you can't figure it out. You're just going to take your best guess, and then we're going to talk about it together in class on Monday. So leave space in your notes because we're going to be adding in the formula here. That's basically what I'm asking you to do, is write me the formula. Good luck.